for this example, form the auxiliary equation and then solve the quadratic equation to get the general solution. So the auxiliary would be 0.5 m squared minus 4m plus 8 equals 0. If you like, you can simplify a bit if I double everything. I get 0.5 times 2 is 1. 2 4s are 8. 0. So I could do that. And then I'm going to put these into the quadratic formula. So A equals 1, B equals minus 8, and C equals 16. And there's an argument to say don't bother to simplify because these minus 8 and 16 are a bit bigger, so you can just as easily leave it as it is, 0.5 minus 4 and 8. But anyway, I put these in to get my values for n, or k, whatever you want to call it. So it's going to be minus 8 is 8, b squared minus 4 times a, which is 1, times c, which is 16, all over 2a, which is 2. And if I've engineered this correctly, we should find that the root is 0 this time. Okay? So in this particular case, if I look at the square root, 8 squared is 64, minus 4 16ths is 64. The root is 0. So we have a solution of the form, the second example on our sheet here, is this particular one here. It's a real, the root's going to be real and the same because the square root is 0. So we're going to get one value for k, and that's going to be the value of k in here. And so our general solution is going to be this, this form, and we've got to find again two constants a and b. So going back to the solution and carrying on with the quadratic, let's find out what k is. 8, so that's 0 over 2, which is 4. So it's a very straightforward quadratic to solve in that case. Because the square root is 0, that just disappears. We've got one real solution, 4. So we know the general solution has the form x equals at, remember we're talking about time, our x is t. Is that how I've written it? Yeah, ax plus b, that's right. So at plus b, e to the 4t. So we now have a situation. There's our general solution. Because we don't know a and b. So if I want to plot this thing, I need values of a and b. So I look back at the problem and I look at my initial conditions. I know that when t equals 0, x equals 0, and the differential is minus 2. So now I've got to put in my initial conditions and find the values for a and b. So when t equals 0, x equals 0.
Mark, we've got minus 4 everyone answering the quadratic equation.
Okay, so putting my values in, if x equals 0, when t equals 0, then actually, if t is 0, looking at this particular part of the equation here, if t is 0, then a is 0. So that cancels out a rather, not saying a is 0, but it cancels that out. And if t is 0, then that becomes 1. So in fact we know that 0 equals b. In other words, b is 0. So there's no b term in there. But what about a? So to find a, we need the second initial condition. We know that when t equals 0, the differential is minus 2. So I've got to differentiate this original function. Because b is 0, then actually it becomes more straightforward to differentiate because I can get rid of the b term in here. I'm just left with at e to the 4t. So we've got that x equals at e to the 4t
Four e to the 40.
yeah. Well, you would think that, wouldn't you? But remember, we've got now two functions involving t. So I've actually got to think of this in terms of calling that bit u and that bit v. I'm using the product rule because I've got t, my variable that I'm differentiating with respect to, appears twice. So now I've got to use the product rule. And again, you'll be given this in the exam, but if you remember, the product rule tells us that the differential is the first bit times the differential of the second plus the second bit times the differential of the first. So all I've got to do is take each bit and differentiate it. So what's u? It's at. And what's v? It's e to the 40. So differentiate each of those. Du by dt is just a, and dv by dt is 4e to the 4t. So plugging them in, x by dt equals u, which is at, times dv by dt, which is 4e to the 4t, plus v, which is e to the 4t, du by dt, which is a. Remember now that when t equals 0, the differential is minus 2. I could simplify that, but actually there's not much point because when I put the initial conditions in, t equals 0, so all these terms are going to become 1, aren't they? So there's, I can actually simplify it quite a lot by putting in my t equal to 0. So the differential is minus 2. So the first term has gone altogether because t is 0. So that's 0. That's gone altogether. And if t is 0, that's gone, so I'm just left with a. So in fact, a is minus 2. So that part's easier. So now I know my constants a and b. B is 0 and a is minus 2. So I'm left, if I go back to my general solution, and substitute in, I've got x equals, so that's minus 2t e to the 4t. And that's the particular solution. So here's the plot. Remember we said the initial conditions were that when t equals 0, x equals 0, so in other words it's starting at the origin, which it is, and then the initial velocity was -2. It doesn't look well. It's difficult to see without zooming right in, but the initial velocity is -2 on that one. So there's our solution.